Let us take a look at using the Salea logic probe. Create a new project. Let's call this Salea. Let's look for digital. PWM is probably easiest. Now the PWM needs a clock because there's a clock input. So let's go ahead and give it a clock. And let's also add one output pin for each of the channels of the Salea. Let's call this one channel 0. Channel 1. Channel 3. I'm going to go ahead and change that name. Let's make this 1 kilohertz. It's a little bit easier to see. And so we have a 1 kilohertz clock going into this PWM. With this period, you'd have, let's say, 32,000 divided by 1 kilohertz. So every about 32, 33 seconds, this will cycle. It's a bit much, so let's do 100. And let's create a compare value of 25. So basically what a PWM is it counts, this will count up to 100. At 25, it will invert the output signal. So with 25, 100, it's going to be on for 25% of the time and off for 75%. And how about let's monitor the PWM with channel 3 of the Salea. And the rest of these, I'm actually going to not have them operate in hardware. We're going to turn these on and off in software itself. All right, well, same as before, we do have to assign what each of these GPIOs are connected to. So I'm going to open my design-wide resources, and we'll just pick some random pins. It doesn't really matter. Taking a look at my proto kit, it seems like 9.0, 1, and 2, and 3 are pretty conveniently located. So let's do channel 0 on 9.0, channel 1 on 9.1, channel 2 on 9.2, and channel 3 on 9.3. Now let's compile it. All right, we're done building. Let's go ahead and use these 3 guys. So I'm going to start with the cortex-m0, which is the primary core. It's a low power core. It's not as fast as the M4, but it's the one that boots up first. I'm going to start our PWM. So just like with the UART, we need to start it up. For the channel 0, what I'm going to do, I'm going to have that pin go high as soon as this core starts. So I have a reference to know when the system is actually operational. So to do that, well, I actually don't know how to operate a pin, so let's see how to access this in software. So I just went to open PDL documentation, and pretty much all of the APIs for all of the blocks will be in here. GPIO functions, and let's take a look at all of the GPIO functions and see which might be useful. So GPIO write looks pretty good. Yep, this will allow me to write our 0 or 1, exactly what I want. So we're going to type cy GPIO write, the port, the number, and what state we want. All right, so cy GPIO write channel 0 port, channel 0 num, and we're going to write 1 to it. Let's also toggle a pin while the CM0 is operating. So back to the peripheral driver library, and let's see how we can do that. So I think invert maybe. So yeah, this will invert the current state. Let's do that. cy gpio inv. Let's do channel 1 this time. Great, and that should be it. Let's do the same thing with the CM4. But instead, we will use channel 2. And I think just to make it distinguishable, let's put a delay before each of these so we can tell which is which. So a delay of 10 milliseconds, the CM0, and we will add a delay of, say, 15 milliseconds with the CM4. Great. Let's go ahead and build that. All right, I'll go ahead and program it now. Doesn't really matter for this. So at this point, you should have the Salea software installed already. And you'll see that we have channel 0, 1, 2, 3. Channel 0 is really both an analog and a digital channel, but we're really just going to use the digital aspect right now. Now, we set channel 0 to go high right at the beginning when it booted up. So we're going to set that as a trigger so it knows when to start collecting. And I'm going to go ahead and start this and hit the reset button. Cool. So you'll see that channel 0. As that CM0 boots up, this signal goes high. Channel 1, which we set to the CM0, if we zoom into here, you'll see that is the 10 millisecond delay that we set. Channel 2 is a CM4, which we had the 15 millisecond delay. And we can see here the PWM has our 25% and our 75% approximately, with our period of 100 milliseconds.